Well, hello everyone, and welcome to the next installation of the videos for the process of building a cave intrusion detector. In previous episodes, I went through an introduction to what it is and why we build them, and the parts that are necessary. I also went through preparation of the four major components of the cave intrusion detector. So with this video, I'm going to start the assembly process and show how it works. I want to start by showing you a completed cave intrusion detector. This is what I call version 2 because it has the memory card interface on the bottom side of the board instead of on the top. That's necessary because of the size of the light detector board. The new light detector boards are larger than the old ones and take up room that was otherwise used by the memory card. So by putting the memory card interface on the bottom of the board, we have room. It also makes the assembly process somewhat easier since the whole board can be wired up before any of the components are soldered onto it. You don't have to put on any of these boards before you put on any of the wires. And some of these wires are going to run underneath the boards. It's hard to tell from here, but for the light detector, the I2C wiring is underneath the light detector board. So with that, let me introduce the base component. This is an Adafruit Permaproto half-size breadboard. This breadboard is organized into a whole bunch of connectors. As you can see, they're on a grid, and the rows are numbered from A through J at the top, and 1 through 30 going from left to right. At the top and at the bottom are two buses which are marked plus minus and plus minus. We'll be using both of those buses. The bus set that's at the top, each row across the top is completely connected to each other, and then the second row is connected to each other. Within these rows, the connections go up and down. So the 5 pins from F1 to J1 are connected together, from F2 to J2 are connected together, and so on. And the same for the bottom set of 5 hole. A1 through E1 are connected, and A2 through E2 are connected. And then the bus structure going across the board repeats for the bottom set. The way this is constructed, we'll use the top set of bus rows for the power and the bottom set for the I2C connections. And then all of this stuff in the middle will be used for other things. The basic layout will have the Arduino sitting right here, as you can see on the original, on the assembly prototype. And then the real-time clock pins go through on this side of the board, even though the board is going that way. The light detector, its pins are soldered in through on row D, and it works this way. And then the memory card is soldered in on row G and points that way on the bottom side of the board. So we will be doing each of those in sequence as we go through. I wrote up a long list of all of the different connections that have to be made, including pin grid numbers, and so I'll just be working through that. The basic sequence of assembly here is to first install the 3 minor components: the transistor, the LED, and the resistor. And then I solder on the Arduino, do all the wiring, and then add the other 3 boards, the real-time clock, the light sensor, and the memory card is the last piece to be put on. And as we go through this, you'll see why that happens. So without further ado, I'm going to start with the resistor. The resistor goes from the resistor goes from D11 to F13. So D11 is right there, and F13 is that one. this resistor is going to be under the Arduino when we get it all done. The Arduino will fit on like this. So that resistor goes under it. The resistor is a current limiting resistor for the LED. Among the tools that you need for this job are a really good pair of small wire cutters. Because once you have soldered those on, you need to clip the two leads off. So that now puts that resistor in the right place. Next item I'm going to solder on is the LED. The LEDs come with one lead that's longer than the other. The longer lead is always the positive lead. We're going to be wiring this between row 13 and the negative bus. Actually, it's going to sit in just like that, with the long lead on the resistor side and the short lead, the negative connection, is on the bus. And notice how I angled it across there. It's one of the lessons that I learned in building some of the other prototypes. By angling it across, I move it just slightly that way, which makes the real-time clock fit a little bit better. In the build template, you'll notice that the real-time clock is sort of interfering with the LED. It's because I made the LED go straight across. So for this one, I'll make the LED go at an angle by one hole. And there we have the LED mounted. And then the last of the three components is the field effect transistor, the 2N7000. 2N7000, as you can see, has a flat side on it. The leads on this going from, if you hold the flat side facing you, the leads on it going from left to right are the let's see, those would be the source, the gate, and the drain. So the gate and the drain are going to go into J25 and J24. The gate goes in J24, the drain, the source goes in J25, and then the drain will go into the negative bus slot, negative bus. And in order to make that look nice, I'll bend this over. One thing to be careful of here is to make sure that the lead that goes across to the negative bus does not touch the positive bus. You don't want that to short out. And so by soldering the two, the gate and the drain, the gate and the source leads first, I hold the thing in place so that I can make sure that the lead going over to the negative bus does not short against the positive bus. And I can see that it's good on that. So okay, with that done, the next step is to solder on the Arduino. The Arduino goes in rows C and G. It could actually go, well, actually it can't because the resistor's in the way. But so rows C and G is where it goes. You could put it in B and F, offset to the side like that. However, that doesn't give you any room along row A to connect in the wire leads that need to go there. So we'll put it in rows C and G. In order to hold that down, while I do the initial soldering, it's useful to take a piece of masking tape and just run it right across here. Just to hold that thing in place for the first couple of solders. So I like to do the first one and the last one on one side, just to get it tacked in place, and then do the first one and the last one on the other side. And once those are done, then the rest of it is just a matter of solder, solder, solder. And so now the microcontroller is held in place quite well. As you can see, it's not moving. So now we can just solder, solder, solder. Okay, and then once all that's done, you inspect it. Need a little more attention. Okay, that looks very good. So the next step is to remove or cut off all of the pins on those. And the way to do that, the way to cut off these pins is to take some cotton balls and put them in an old butter tub. The cotton balls keep the pins from bouncing. When you cut them off, they come off with a fairly good velocity, and they can easily bounce out of the butter tub and go all over the place. These little pins are a pain to step on. So yeah, see, that one bounced. And then give it another inspection just to make sure. And yep, that one is looking pretty darn spiffy.